Hello, my name is John Cranner and welcome to my YouTube video channel called Science Experiments for Home Educators. I home educated my son when he was from the age of 12 to 16, and I built up a large range of equipment and chemicals, mainly to teach him chemistry, but it also included stuff on physics and biology as well. What I'm going to be doing in this introduction video is just showing you the range of practical equipment I've got and how they're used in the videos. And later on I'll be doing individual videos showing the different experiments that I did in chemistry, physics and biology. Well, the first part of the video shows all the range of equipment I've got in these cunningly disguised boxes. And what I'm going to be doing is going through each box in turn, showing you what I've got. This is from Virgin Wines, which took me quite a while to acquire, a few weeks or even months. Right, here I have laid out in front of me all my chemistry glassware. And first of all, the most important piece of equipment, I suppose you should look at, is the safety wear. So we have a rather mangled mask, but it's quite useful to have a face mask if you've got any fumes around. I've got some quite heavy duty gloves for dangerous chemicals, glasses there to protect your eyes, and a rather cheap but quite useful white coat just to go over your clothes. Right, perhaps the most iconoclastic piece of equipment are the test tubes. So we've got some test tubes here in a plastic test tube rack and a test tube holder. So you can hold the test tube. And the other piece of equipment which you always see in chemistry labs is the Bunsen burner. So here we've got it linked up to a camping gas stove. And the next piece of equipment we have are the beakers and flasks, or Erlenmeyer flasks for some reason. Now these are useful for pouring in chemicals and combining them and mixing them. They do have measurements for the volume, but they're only rough measurements. The next set of equipment I'm going to be showing you is the more accurate measurement of volume of liquids. We've got these three measuring cylinders, so they go up to 50 millilitres here, 100 millilitres for that one, and 250 millimetres there. So they're used for more accurate measurement of fluids. And then even more accurately, we have these two different pipettes. We have a straight pipette and we have a pipette with a single volume. And then we've got this piece of equipment here which is used for drawing up the liquid. So you rotate that thing and it brings it up, and then you take it up to the right measurement at the bottom of that mark there. And lastly, we have this other type of pipette here which is used for titration. So you've got accurate measurements along there, and you've got a concentration of liquid there which you want to find out, and you run a known volume of this in here, and you have an indicator in there, and when it gets to the right point, because you open it there and you just go in drop by drop until the colour changes, and then you can measure the concentrations of this unknown liquid in there. And the next piece of equipment I'm going to be showing you is this flask here, this what's called a beehive, and the flask is attached to a rubber tube that has this bent glassware here, and what we have is these glass jars here, and they're used for producing gases. So what you do is you put your two reactants in here. We can produce either hydrogen or oxygen, and in this bowl here you'll have water in which you'll put that beehive in. But if I just take it out, then I can show you how it works. So that'll be underwater. So you have your reactants put in their gas, then put a bung over there, so all the gases come out that tube, then goes through here, underwater, and through the beehive, and comes out there. And then you have your glass jar, which is filled with water, and you put it over there, and as a gas bubbles out, it displaces the water and pushes the water down. So eventually you have this jar that's full of gas, and then you slide it out, have this coated with Vaseline so it provides a water airtight seal, and put it over there. So you have a jar that's full of your produced gas, either oxygen or hydrogen. And finally, on the glassware section, we've just got these various miscellaneous bits of equipment here. We've got this, which is a long hollow tube, which is called a combustion chamber. And what we can do here is we can have gases, or rather liquids that produce a gas. We can put in cotton wool at each end, and we can see where a reaction occurs in the middle of the tube. That's why it's called a combustion chamber. We've got this, which is called a conflagration chamber, and that's put in one of those jars when we've got gas, and it can hold a chemical there, and we can see the different reactions when it's put into something like pure oxygen. Especially when we burn sulfur, we can see a different flame there. We've got 3 different types of brush to clean test tubes and bigger tubes, flasks, different sizes there. We've got pipettes here for just putting small amounts of liquid from one place into another. We've got these spatulas, so we can put small amounts of chemicals into our holders. Got glass stirrers here, so we can mix our chemicals in our beakers. We've got here some evaporation bowls here, so we can mix chemicals and then evaporate the liquid. And then we have a whole range of Petri dishes here, which are quite useful just for holding things like solid mercury, which I'll show you later, and we can also do a nice diffusion experiment in it. And there we have a thermometer, so we can measure temperature. And lastly, on the measuring side of things, I've got 2 weighing scales here. One just a basic kitchen scales here, which will do measurements to the nearest gram. And then for more accurate measuring, I've got here a set of weighing scales that will measure up to the nearest 1/100th of a gram. Although, because it's a smaller set of scales, it will only go up to, I think, 200 grams. And next up, we have my full range of chemicals, my chemical supplies. Now, I've got ranged up here at the front the chemicals that you can get from the local shops around you. For instance, this I've bought from a hardware shop, that's sodium hydroxide. So that can be almost as dangerous as concentrated acid. So that's can be a very strong alkali. So that's also why I've got the gloves on, because you don't want the chemicals to leak out and go into your hands. And this is ammonia, so that's fairly weak concentration. I have got a stronger one that I bought from a chemical supplier. So that was from, I think, from Wilco's. That's 9% ammonia, although it's not ammonia itself, because with it in water becomes ammonium hydroxide. Agricultural supplies, you can get copper sulfate. From the garden store you can get sulphur. This was bought from Boots. In fact, it says Boots at Epsom salts, which is known as Epsom salts, but its chemical name is magnesium sulfate. Desiccant crystals or absorbents. That's calcium chloride. So that's used in making plaster of Paris. That one. Glycerin, which is, you can do a good fun experiment mixing glycerin with potassium permanganate. I don't. You used to be able to get that from Boots, but you can't anymore. But you can get it from Amazon. And this was from B&M. It's artificial nail and tip remover, which is actually pure acetone. And now these are the stronger, more potent liquids. So I was pointing out to you before that you could get ammonia from the local store. This is a much stronger version of ammonia, that's 33%. We've got 2 bottles here of hydrogen peroxide, and that's used to make oxygen. And you can also do a good experiment called elephant's toothpaste with it. And we've got the range of acids here. We've got a strong sulfuric acid, which you used to be able to buy at your builder's merchants as drain cleaner, but now it's illegal to do that without a license, without being a school or a scientific establishment, because of all the people who are using that to throw at people and cause burns. And then we've got some hydrochloric acid, which is 36%. That's it. It's still quite strong. We've got a weaker sulfuric acid, but that's of the known concentration 1 molar. So that's the type of thing that you could use in those titration experiments when you want to find the concentration of another liquid. And this is nitric acid, which is, I don't know what percentage that is, but that's 1.42 specific gravity. And this, more nitric acid, not the same, and some hydrochloric acid, 28%. And the rest of the chemicals we've got here are various powders, solid compounds, which are used for just various different chemical reactions. So we've got calcium hydroxide, we've got zinc oxide, zinc carbonate, manganese oxide. We've got somewhere there's, oh here we go, potassium permanganate, which produces a very strong purple colour when you dissolve it in water. But it's also used for that interesting experiment when you mix it with glycerin. So that's our full range of chemicals. The next molecule building kit I've got here is a kit for doing a model of the DNA. It does 1 turn of it, and there's a close-up of the box lid there showing what the molecule looks like. So it doesn't have each atom individually built up, but it has representations of the atoms. So there's the 1 pairing of the complementary bases that form the spine of the model, and these are the these red and purple are the phosphates and the deoxyribose atoms that go around the outside. So in the instruction booklet on how to build the model, it does give a detailed layout of the atoms that are in the complementary base pairs. So there's 2 sets of base pairs, one that connects thymine and adenine together there, and the other one that connects cytosine and guanine together. And to actually show those molecules there with the individual atoms, what I then used is this kit here called the Orbit molecular building system, that's got a really nice tatty top because that's where my dogs decided to have a chew on it. So this is what the actual kit looks like, and actually these are 2 models I made here. One, well I can't remember which is which, but one of CT and one of GA, guanine, adenine and cytosine and thymine. So you're able with it to build up large structures like this, which is a representation of diamond. And here you've got a representation of a sodium chloride crystal. So that's the chlorine and that's the sodium. So they're alternating atoms when they're in the crystalline structure.